We have done till bulk modulus, right?
Yes, sir.
There is one more ratio here that we call Poisson's ratio. Poisson's ratio. What happens that if any rod or any wire is subjected under some force, let's suppose you are applying some force here, F. So what will happen? Let's suppose here the actual length when no force was applied, at that time its length was L and the radius was, this radius here is R. This radius is R. When you are applying force, the length increases. It becomes L plus delta L. But at the same time, the radius is decreased because it will be slight thinner. So radius will be R minus delta. So when the length is increasing, that delta L by L is called longitudinal strain, that we already know. This is longitudinal strain. But radius has decreased. How much decreased? Delta R by R is called lateral strain. Lateral strain. Lateral strain. So Poisson's ratio. Poisson's ratio is basically, that is written by sigma, that is the ratio of lateral strain divided by longitudinal strain. Longitudinal strain. So we can write that sigma equals to delta R by R divided by delta L by L. And some minus sign is there because when the length increases, the radius is decreasing. You can write here minus delta R into L divided by small r into delta L. That is the Poisson's ratio. Understood?
Understood, sir.
Okay, please write.
Yes, sir. Done.
Okay. So this chapter is finished. Now we'll solve few questions on this. Okay. Hmm. You have not sent now that this chapter questions study package. I will take. You have my Akash app.
The Maya ka, sir? Yes,
There you will also find na, your target book.
I think so.
Hmm. Okay. Today you send. Meanwhile, I am taking from that Akash Guru questions you given, no, that I am taking. Okay.
Oh,
Like question number 5, you can see here. You can see question number 5 there.
yes.
A metallic bar of mass m, length l, area of cross section a, Young's modulus y is pulled by two forces as shown in the figure. What is the total extension produced? It is given that you have a metallic rod. This side we are applying force 5F. This side we are applying force F. Length is given as L. Area of cross section is A. And Young's modulus is given Y. What will be the total extension? Do you remember this case? What we do when both side different forces are there? What we do, Neil?
Uh, no, sir. Yeah.
You check the notes. These conditions I have discussed. What happens when both side different forces are there?
Both side different forces are there. Basically, we have to use that elastic potential energy.
No, no. Extension delta L you have to find when both side different forces are there.
delta L1 plus delta L2.
Different forces are there in one rod only. There are not two rods, delta L1, delta L2. That is when two rods are connected in series. First class you check
Okay.
of this chapter.
Right. Was
Have
that
you got?
first formula of Young's modulus, no?
Okay.
So y is equal to f upon a upon delta L upon L is equal to f times L.
Just check this. This example have you written?
Example. Yes, I've written
Yes.
it.
Both sides different forces are there. 3F, 2F. Then
Yes.
how we found the stress? What we have done in this case?
In that case, we had done f upon 2a.
F upon
Find out
2.
the stress.
You see this in this condition also you have written different forces are there. F1 towards left, F2 towards right. Then how you found the stress?
That f1 plus f2 upon 2 yeah, upon a.
That we have found the average now of two forces.
Yes, yes.
That I am saying. This condition, the question that I have taken is the same condition na, here. You can see here also 5F and here F. So what is the stress here? Can you tell me what with the how do you find the stress? We'll take the average of these two force. F
Take
force
average of f and 5f upon
F plus
5f.
5F upon 2, right? That is 6F upon 2. That is
Yeah,
3F. Correct?
yes.
And we know that Y is equals to stress divided by strain.
Strain.
So Y equal to stress is 3F and strain is delta L by L. We have to find the extension delta L. So Y will become here. I can say 3FL by stress is area also. Area I have not written. 3F by A. So 3FL divided by AY. That should be your answer here. First option. Actually, directly also you can remember in such condition delta L, if when two forces are there, we should write that F average into L divided by AY. This you apply when different forces are acting at both ends. Different forces are acting at both ends. You understood? Now you remember the conditions.
Yes, sir. Understood.
Now let's check. This you have written, na? This example you have written.
Oh, yes, sir, I'm writing.
Okay, please write.
Yes, sir, done.
Next question you see, question number 6. First read the question.
Yes, sir, I will do it.
You try what they are saying, or what to do steps you tell at least.
Okay, sir, just once.
It is given that a wire elongates by x mm when a load W is hanged from it. If the wire goes over a pulley and the two weight W each are hung at the two ends, then elongation in the wire. First condition is given that a wire, if this is the wire here, and a weight W is hung, then in that case, here the elongation is x. But if I change this as a pulley and same wire I keep like this side and this side both are having same same weight, na? W here also W. Now in that case, how much elongation will be there? So if you Elongation depends upon here forces. In the string here, how much tension it will be? Tension will be weight only. And here also what you see, the tension will be equal to the weight only. Okay, in both conditions there are same force. T equals to here weight, and both sides same weight means particle is not moving, it is in balance only. So T is equal to, it is very much similar to that case that I have taken when you apply both ends force F F, or you apply one end force only and other end is fixed, and one end you are applying force. I told you in both case stress will be same. If you remember, we have discussed in both case stress will be same. And if the stress is same, then strain will be also same. So in this condition also, the elongation will remain same x. If here it was x, here it will be also x. If you would have applied different weights at both ends, then the elongation might change. But you have applied the same weight. That means same force F, F both sides. So stress will remain same. Do you understand, Neil?
Yes, sir, understood.
Please write it.
Yes, sir, done.
Okay. Next question, number 7. It says that a rigid rod of mass m, length L, is being rotated with angular velocity omega about a vertical axis passing through one end A. The tension in the rod at end A is TA, and at distance L by 3 from the end is TB. Then what their question is there? Okay, TA and TB ratio they're asking. TB equals to TA by 8, TB equals to TA by 9. What is TB equal to 8 by 9? And TB equal to TA by 7 by 8. Okay. So this is also a very good conceptual question about rotating rod. Let's suppose you have a rod here. And this rod is rotated about one of its end, that is the axis, and rotating with an angular speed. This is very good conceptual question based on rotating rod. Rotating rod. So its mass is given as m and length is given as. If you see closely, then you find that at T here, at the end here A, what is the tension? At the end A, it is rotating the complete rod. And where I'll keep the mass, I'll keep the mass at the center. Normally, I keep the mass at the center. And it is moving in a circle. It is moving in a circle. So I can say that the tension average that we can find here at A is centripetal force m omega square, and the distance I'll take as L by 2. So m omega square L by 2. Okay, understood. Can't hear you, Neel.
Yeah, sir. So, um, Rush.
Okay. Now it is same rod I'll take, and now it is taking L by 3 at some point here. That distance is L by 3. Now here one tension will be outside this side and one tension will be inside. One force outside, one force inside. Now you see that here the tension should be that much which can rotate this part of the rod. This part of the rod is of what length? It is length of 2L by 3. So its mass will be also 2m by 3. So here how much tension is required? Tension at B. Same formula I am going to apply. It will be m omega square L. So m here is 2m by 3 into omega square. Now this mass will be also at the midpoint. Always the mass is the center point. Total distance is 2L by 3. I'll take half of it. So it becomes L by 3. It becomes L by 3. So here what I am getting here, I am getting here is 2m omega square L by 9. That is tension at B. If I divide tension A and tension B, then it is m omega square L by 2 divided by 2m omega square L by 9. M omega square L cancel. It looks like 1 by 2 divided by 2 by 9. So it becomes here 9 divided by 4. Okay, understood?
Okay, sir. Yes, sir. Done.
This question also we have to. Okay. One end of a uniform bar of weight W1 is suspended from the roof, and weight W2 is suspended from the other end. Okay, this question is also good question. You have a uniform bar here. It is suspended. Its weight is given W1. And another weight you have taken that is suspended from the other end, W2. Area of cross section of the bar. This area of cross section is A. Now they are asking what is the stress at the midpoint of the bar. At this point here, what is the stress? So just check at this point what is the force acting. Okay, what is the force? Because stress formula is force by area. Force I am writing as a tension. So at this point, this is holding this much weight, this tension is balancing this much weight, that is half weight of the rod. So W1 by 2, and also balancing the weight of the block. So I can say that T is balancing half of the rod, that is W1 by 2 plus W2 is the weight of the block. So F by A if is there, so I can say the answer should be W1 by 2 plus W2 divided by A. I think third option should be correct. Please check and copy.
Yes, sir. Done.
Okay. Okay. Question number 5. If force F of 20 Newton is applied on a rod of uniform cross section area 5 by 3 and length 2. Modulus of elasticity is given 4 gigapascal. Find the value of elastic potential energy stored in the rod. Elastic potential energy formula you can apply as half uh, into stress. We have discussed is half into stress into strain into volume. Let's suppose strain is not given, so you can also write in terms of stress also. We can say strain is equal to stress divided by Young's modulus, because Young modulus is a ratio of stress and strain. So we can write that the potential energy is 1 by 2 into stress multiplied by, you can say here, stress by Young's modulus into volume. So this becomes here stress square. Stress square divided by 2 into Young's modulus into volume. Now in this question, stress force you need is given, area is also given, do the square, Young's modulus is also given, and the volume is area into length, that is also given. Just put all the values and tell me what answer you are getting. Okay.
Okay.
Giga is 10 to power 12. Are you doing, Neil?
Yes, sir, I'm doing.
Yeah, yeah. Please see which option coming. Check the options. Here stress is F by A or F by 2A, Neil. What do you think? What will be stress in this condition? F by A or F by 2A? Because this side we are not applying any force.
Yes, sir.
So should we take the average?
Yes, sir, I think so.
Yeah, so F plus 0 by 2. So it should be F by 2A, right?
Yes.
Yeah. Now try. Okay, this calculation you can do later. No problem. Question number 6, you tell. You understood now how I am solving?
Yes, sir, I understood that. Will it be option 167
Yeah.
times 10 raised to minus 3j?
Yeah, correct. Question number 6.
Okay.
Hooke's law is valid for proportionally limit, right?
Yes, yes.
Okay. Question number 10 will check.
Okay.
Two wires are made of same material and have the same volume. However, the area wire 1 has a area A and wire 2 has a area 3A. This wire has area A. Same material means Young's modulus is same. Other wire has same Young's modulus, but area is here 3. But their length volume are same. So its volume is L1, length is L1, and here length is L2. Then volume means area into length. It is given that A into L1 is equal to 3A into L2. Means it is given that L1 is equal to 3L2. Now, uh, if the length of the wire 1 increases by delta x after applying a force F. So if I am applying a force F on the first wire, here in that elongation is delta L is equals to delta X. How much force is needed to stress the second wire? Let's suppose how much force I am writing the force F dash here. How much force is required to stress the wire 2 by the same amount? Here also elongation in the second wire should also be equal to delta X, right? That they have given. So first I write the formula. Delta L formula is F into L divided by A into Y. So in first case, if I this formula I am using, if I say delta L1 is equal to force I am applying F, length is given L1, area is given A, and Young's modulus is 1. In the second wire, delta L2, force I have applied F dash, length is L2, area is 3A into Y. So it is given that the both are same. Both delta L1 and delta L2 are same. So if I equate that, delta L1 is equal to delta L2. So delta L1 is F into L1 by AY, and delta L2 is F dash into L2 divided by 3AY. AY and 3AY AY cancel. L1 also is 3L2. In place of L1, I can use F into 3L2 is equal to, this is F dash L2 by 3. L2 cancel. 3 you can multiply that side. That becomes 9F. So 9F is equal to F dash. That means the force should be, F dash should be 9 times of F. Third option looks correct, Neel. If understood, please copy.
Yes, sir.
Done.
Just one second. Just one second. Yes, sir, done.
Now you also, when you have the book now, from that book also you solve yourself. Okay.
Okay, sir.
Let's suppose I take one example. Here a particle is 2 kg and here a particle of 3 kg. Young modulus is given 2 into 10 to the power 12 Newton per meter square. Area of cross section is given 1 centimeter. We have to find the extension in the wire. Extension in the string. Formula that you have to use is delta L is equals to F into L by A into Y. L is also given as 1 meter. By using this formula, just show me the answer. Tell me the answer, Neel. Okay.
Okay, okay.
How to
Yes.
find the force? You got the answer?
Yes, sir. Yes, sir.
See, how to find the force? That is, the force here is tension in the string. This side is 2g, this side is 3g. So I can take, the body is going down. So I can take here 3g minus t is equals to 3a. This body is going up. So I can take t minus 2g is equals to 2a. If you add these two, it becomes 3g minus 2 is g is equal to 3a. So a you are getting as g by 3. By putting the value of a in equation first, that is 3g minus t is equal to 3 into a you have found g by 3. So it means that t I am getting as 3g minus 3g by 3. So 9 minus 3, 9 minus 3 is 6g by 3, that is 2g. So tension is 2g, that is 20 Newton. So here you can use 20, length is 1 centimeter square is 1 into 10 to power minus 4. Young's modulus is 2 into 10 to the power 12. So this is here 10 minus 4, 12 is 8. So 10 into 10 to the power minus 8. That is 1 into 10 to power minus 7 meter is the answer. You got that much?
Yes, sir. I got that.
Okay.
Mm.
Now you solve from your book, okay?
Okay, sir.
Okay. Bye.
Bye, sir.